Bismillah ar-Rahman ar-Rahim. Let's continue. One of the assumptions in EOQ model was that the demand is constant and the stockout cannot occur. But in the lead time, which is possible that the demand is uncertain, and we will see the case. And in that case, we have to keep some safety stock such that we don't have a stockout condition occurring. So if demand or the lead time are uncertain, the exact ROP will not be known with certainty. So exact reorder point will not be known with certainty because the lead time or the demand is uncertain. To prevent stockouts, then it is necessary to carry an extra inventory called safety stock. So instead of just keeping some ROP reorder point inventory, we will keep some cushion and we will call it a safety stock, so that if there is an uncertainty, then this stockout doesn't occur. Safety stock can prevent stockouts when demand is unusually high. Safety stock can be implemented by adjusting the ROP. So let's look at that. We have ROP is equal to D into L. We have discussed this earlier, but now we are adding this safety stock here. So the reorder point will be then including the daily demand into lead time plus some safety stock, and that will be the reorder point. Here we are showing that if the demand is uncertain during the lead time, then it may turn out to be a stockout. So what we do is we add a safety stock as a safety stock, which is some kind of a cushion we have added. So if there is some uncertainty, we can avoid the stockout. Now ROP reorder point with known stockout costs. Now there are two situations. One is that we know the stockout cost, and another is the situation when we don't know the stockout cost. With a fixed EOQ and ROP for placing orders, stockout can only occur during the lead time. Now objective is to find the safety stock quantity that will minimize the total of stockout cost and holding cost. Now our objective is to find the safety stock quantity that will minimize the total of stockout cost and holding cost. Now we have a situation that stockout may occur and then holding cost is there. If we keep large safety stock, then of course chances of stockout is not there, but then we are keeping a large safety stock for which will be kind of it has a holding cost. On the other hand, if we keep less safety stock, the chances of stockout cost may occur. So we want to find a balance between that. We need to know the stockout cost per unit and the probability distribution of demand during the lead time. So we should have in order to find out in this objective that we minimize the stockout cost and holding cost, we should have a probability distribution of demand during the lead time, and of course we should know also what is the stockout cost per unit. Now estimating stockout cost can be difficult as there are direct and indirect costs. Direct costs are obvious, that we lose a customer, we wanted to sell, but because of the stockout we are not able to sell it, so we didn't or we were not able to use this inventory because the stockout occurred. But indirect costs are difficult to find, and they are sometimes the indirect cost could be very high. For example, I in the earlier when I discussed this about inventory controls, we discussed that the stockout costs sometimes are very high, such that you cannot put a price tag on it, such as the stockout of a life-saving drug. Also, stock out indirect costs cannot be measured easily. For example, if there is an unsatisfied customer, he may, you lose a customer, you are not able to sell it, and also maybe he is also in the future perhaps will go to to your competitor rather than coming to you. So these indirect costs are there, which are not easy to evaluate. Now let's look at this example here. We have a company which has determined its ROP 50 units, but of course in this lead time there is a chances of sometimes there is a less demand, sometimes there is a high demand. The carrying cost per unit per year is $5 and stockout cost is $40 per unit. So the carrying cost, the holding cost per unit per year is $5 and the stockout cost we are saying is $40 per unit. The probability distribution of demand during lead time is shown below in this table here. We have for example the number of units during the lead time, 30 demand, 30 units, the probability is 0.2, 40 units 0.2, etc. And we have this is, let's say we are calling it ROP, that most of the chances are that 50 units if we keep it, we will be able to supply most of the time. But of course the chances of 60 units occurring demand and 70 units occurring demand is also there. So these are the probabilities involved here. And we have also the optimal number of orders per year is 6. This means that this situation can occur 6 times because we are ordering 6 times in a year. So this situation can occur 6 times in a year. Now, determining the safety stock level that will minimize the total expected cost is a decision making under risk problem. What we will do is we will make these alternatives here. We are keeping this inventory 30 units, 40 units, 50 units, 60 units and 70 units, and then we have a demand during the lead time which could be 30 units, 40 units, 50 units, 60 units and 70 units, and we will see that what is the expected value coming. So for example, let's look at the row 1 over here, ROP 30. We keep 30 units during the lead time. Then if the demand is 30 units, we will not have either the stock out, or we will not have any holding cost for these extra units, because we are keeping the 30 units, 30 demand is there, so no extra cost coming here. Let's say we have kept 30 units and the demand became 40 units. Okay, so then there is a 10 units of stock out, right? 10 units of stock out has occurred. Now we said that $40 is the cost per stock out, per unit of stock out, per stock out cost, or per stock out, let's say, or per unit of stock out. Then if it is 10 units because we said that 30 we kept it, 40 demand was there, 10 units are extra demand is there, then which means that 40 multiplied by 10 is $400 is the extra cost coming. Now remember that we said that this happened 6 times. This happened 6 times in a year. So annually the cost will become multiplied by 6. 400 multiplied by 6 will become $2,400. So this is the cost if 40 units demand occur, which means it occurs 6 times in a year. So this is the cost coming, $2,400. If we kept 30 units and the demand became 50 units, then 20 units is the shortage. 20 units stock out is there, so which means that we have 40 multiplied by 20 multiplied by 6 times, and what we get is $4,800. So this is how this came, and similarly for 7,200 and 9,600. Now, how do we get 4,320 expected monetary value? Just multiply this number here, 0 multiplied by a probability of 0.2 plus 2,400 multiplied by 0.2 plus 4,800 multiplied by 0.3 plus 7,200 multiplied by 0.2 and 9,600 multiplied by 0.1, and we get the expected monetary value. You have learned these things in decision analysis, how to calculate the expected value. So this is just the multiplication of these numbers, these costs, into probability, and we get the expected value. Now let's look at a situation of we keeping 40 units and the demand occurs 30 units. Now what happens? Now we kept 40 units, but the demand was only 30 units. This means that 10 units are extra. Cost is coming because of keeping this extra 10 units in the inventory. This means we have $5 per unit per year is the cost of holding. Then 10 units we are holding it for 1 year, so this means that $50 is the cost. Remember that this time we are not multiplying by 6 because the cost of holding is given in $5 per unit per year. It is not per unit per order, it is per unit per year. So this is the cost multiplied 10 multiplied by 10 is $50. So this is $50 came here. Now on the other hand, if we kept 40 units and the demand was 40 units, we don't get any holding cost or the stock out cost, so it is 0 here. And then again we continue like that. If we kept 40 units and the demand was 50 units, the shortage of 10 units occurred, and this occurred 6 times, so it is 2,400 and so on. And then we calculate the expected monetary value by just multiplying these numbers. Let me show it how this is calculated. Let's say EMV is equal to 50 multiplied by 0.2 plus 0 multiplied by 0.2 plus 2,400 multiplied by 0.3 plus 4,800 multiplied by 0.2 and plus we have the last one is 7,200 multiplied by 7,200 multiplied by 0.1, and what we get is the last figure over here, $2,410. So in this way all these numbers have been calculated, and you can see that the cost since we are trying to minimize the total cost, the total expected value, we can see that if we keep 70 units we get the minimum over here. It's not necessary that we keep more units and always the expected value will be less. It is possible that we have a minimum occurring like that we keep more units here, and then this will be the minimum cost here sometimes. But in this case all the costs have gone. As we keep increasing the number of units, the cost has gone down, it didn't increase. Now this is the explanation which we have already explained, so I will not spend time on this one. You can look at it again, and this is the minimum cost coming over here. So we will keep 70 units in ROP, which means that if 50 unit is the normal ROP, then safety stock is of 20 units. So total is we are keeping 70 units. Now the situation is that we discussed that stock out costs are known. What if the stock out costs are unknown? In that case we can express a service level. Okay, we say that we can have a service level of 95% or 99%. We define a service level, and according to that we can calculate the cost of keeping these or not cost of keeping, because the stock out costs are not known, but we can know that how much number of units we have to keep extra as a safety stock. So service level is equal to 1 minus probability of stock out, and we can define a service level 95%. This means that probability of stock out is 5%. If we define service level 99%, then of course the probability of stock out is only 1%, etc. Let's look at this example over here, Heinz-Dale Company example. We have inventory demand which is normally distributed during the reorder period. This is the demand during the lead time, and mean is 350 units. So mean coming is 350 units and the standard deviation is 10. So we have both this coming from, let's say, from the past experience, that mean is 350 units and the standard deviation is 10 of this demand. Then they want stock out to occur only 5%. So what we say is that we can live with the 95% service level. 5% stock out is fine with us. So this is their standard, let's say. So we have here the mean demand is mu is 350 and standard deviation is 10, and x is, if you look at this figure 6.9 here, you can see that x is the thing which is unknown to us. We can easily find out, but we are only interested in safety stock here, SS. So a safety stock is equal to x minus mu, and we know that if we want to use the normal standard distribution, we should find out the normal standard deviation. Normal standard deviation is z. So z is equal to x minus mu over sigma. That will give us the normal standard deviation of z value, and we can find out the z value. From this z value we can find out the safety stock, because z is equal to sigma and sigma is known to us. Now how do we find z? Z is easy because now we can use the normal tables, and here we are showing the table here, and we can say that we said that the service level is 95%, 5% stock out. So 95% is our area, which means that 95% of the time we should be able to supply our demand, so to meet our demand. So 95% is somewhere here, which if we read from here, this is the z value 1.6 and on top of it is 0.05, so z becomes equal to, z is equal to 1.65. 1.6 from here and 0.05 from there. So we have, from this table we get 0.95, which is 95% of the area of the normal distribution. So from appendix A we find z is equal to 1.65, and from here we can find out the safety stock, which is equal to 1.65 z into sigma. We get 16.5 units or 17 units. Let me go back actually. Okay, so this is on the 17 units. If we keep 17 units, we will be 95% of the time there won't be any stock out. Let's continue. Different safety stock levels will be generated for different service level. However, the relationship is not linear. You should be aware of what a service level is costing in terms of carrying the safety stock in inventory. The relationship between Z and safety stock can be developed as follows. We know that Z is equal to X minus mu over sigma. Then safety stock is X minus mu, and thus we can use this formula here to find out Z. Here we are showing that for the same example, where sigma was equal to 10 standard deviation, then what we have is Z value for 90% service level. Z is 1.28. Sorry. Z is 1.28, and then the safety stock will be 1.28 Z into sigma, which is 12.8, and again and if we are assuming over here that the carrying cost is $1 per unit per year, so 12.8 multiplied by $1 per unit per year is 12.8. And this way we can calculate the whole and we can plot it, and the plot is coming here: service level versus the annual carrying cost. As we started from 90%, we can see that how much safety or inventory carrying cost is then. And then as we increase, initially it is rising linearly, but then there is no linear relationship here, because as we are going 99% and 99.99%, then it's exponential rises there. So this is shown over here, although it is done for a specific case, but the general shape of the curve is the same for all service level problems. Using Excel, we can of course use Excel, and so this is showing the service level and how the cost is increasing. A last topic is about very small topic is about ABC analysis. ABC is the purpose of ABC is to divide the inventory into three groups based on the overall inventory level value of the items. We can make group A, group B, and group C. That's why it's called ABC analysis. Group A is typically about 70% of the dollar value, but only 10% of the quantity of items. So this is expensive items there, only 10% of the quantity of items. Forecasting and inventory management must be done carefully for this group A, because this is an expensive item. 70% of the dollar value is tied up to this item. So this is we have to do it properly. Group B items are more moderately priced, may represent 20% of the cost and 20% of the quantity. This is group B. And for such kind of group, maybe we can think about that we can have it inventory control, or we don't want it. Depends on our how much cost is involved there. And in the group C item, a very low cost but high volume is there, so it is not cost effective to spend a lot of time managing these items. So basically what we are saying is that this is the summary of ABC analysis. When we have the inventory group, we group the items. The inventory items are 10% only, but the dollar value is 70%. Are quantitative control techniques used? Yes. For group B, the dollar usage is 20%, and the inventory items are also 20%. In some cases we can use that. And for group C, the dollar value is very less, and inventory items are maybe large, 70%, and there is no need to spend time and effort on controlling this inventory. So here is an example of a silicon chips incorporation example. We have 10 items here, 10 inventory items are there, part numbers are just given, and the annual volume of units is there, how many number of units are needed, and this is the demand of these total in a year, and we have the unit costs here. So we can see that some items are expensive, like we have $154 per unit is item number 7. Similarly, item number 3 is there, which is the 1000 units are there, and the unit cost is $90. And then there are some items which are very cheap. For example, item number 10 is only 60 cents and its volume is 2000, and so on. So let's see how we can group these items just using the same we can say a rule of thumb that we have item 3 and 7 are expensive, and the total cost of these is coming about dollar value is 90,000 and 77,000 for these items. If we add these dollar values of the total value of 232,000 here, it is coming as summation is coming about cumulative value is 71% or so. So we can say that the first two items we should be doing definitely about inventory control, and these are the two items for them we will do the inventory control. For inventory B, which is roughly speaking is 20% of the items here. It is because the items are not finally going into in a fine tune by having 20% or so. So we have coming like maybe from 71 to 95, it's about coming about 24% or so. These three items can be grouped in group B, and then we have the third 5 items which can be put in rather 2 items may go into group B, and then because it is 89.78%, and then this the last 5 or 6 items can be put in group C. The idea is that we group the inventories into group A, B and C, and then we can just concentrate on group A more. Group B, we can decide about that we want to concentrate for the inventory analysis or not, and then group C we can just leave it. I think this is the last topic here, and we just stop it here. So in nutshell, what we can say is that what we have learned in inventory control is there are 2 things which we control: how much to order and when to order. We looked at a basic EOQ model, economic order quantity model, in which there were several assumptions. For example, the demand is constant and known, the lead time is known and constant, there is no stock out occurring because of these because we know the demand and we know the lead time exactly, and the demand is constant, so there was no stock out there. We said also that there was no discount as well, so our system was became simple. Only ordering cost and carrying cost was there, stock out was not there, no discounts were there, so our purchase price or the cost of the item was also constant, so we neglected that. And what we try to find out is that the model, by equating the ordering cost, annual ordering cost with annual holding cost, we said that the cost is minimum, and then we found out the formula for that economic order quantity model formula, and we just use that formula to find out how much we have to order each time. This was a simple model, EOQ model. Then we try to relax some of the assumptions. One of the assumption in EOQ was that the inventory received in a single batch, but then we said that what if we are producing something, production is going on, and we are building the inventory. So we look at the production run model, and then we saw how the formulas are modified, the same EOQ formulas, which was slightly modified for having the production run model. Then we look at the situation in which we can have the discounts are there, quantity discounts are there. In that case, how to take into account? We said that we should now look into three costs. We have the ordering cost, annual ordering cost, annual holding cost, and also the purchase cost also, so that because now purchasing cost or the cost is now not fixed because we are getting some discounts by ordering more. Then we try to find out the total cost and minimum total cost. We saw that how to find out the minimum total cost by looking at the discounts, at what level the discount is, and putting that at minimum level, and then ordering that much. Then we saw that again we relaxed the assumption that lead time is not constant, but it may change, and in that case what will happen is that stockout may occur, and there are two situations. One is the stockout costs are known, and in that case what model we can use, we have seen that we can find out the expected monetary value and try to minimize the cost there. If on the other hand the stockout costs are unknown, then what we have to do is we have to say that service level, what service level we are willing to accept, and according to that we can find out how much safety stock we have to keep. This is the basic things what we have learned in this chapter. I think there isn't anything left in the the last topic was very simple about grouping the inventories. We can say that the group A is 70% of the dollar value is tied up to that inventory, which are less in quantity, but their dollar value is more, which is about say 20% or so. Is the they are 20% in number, but their dollar value is about 70% or so, something like that. And then we group the B, in which the inventory items is only 10% and the dollar value is 70%. Group B is we have the dollar usage is about 20%, and the inventory items are 20% also. We can for group A we have to we should do it the quantity control techniques to control this inventory, but in group B in some cases we can do it, whereas group C is the dollar value of this item is low, maybe 10%, and the inventory items may be large in number, 70% or so. In that case there is no need to do a fine control of that. I think I will stop it here, and we will continue with another topics then.